All right, guys. So in this video, we are going to continue talking about the rational root theorem, but this time we're going to see an example when the leading coefficient is not 1. So in our previous example, the leading coefficient was 1, but here we actually have a 2 in front of x cubed. So that's going to make the search for the rational roots slightly harder. So first you're gonna again start with the constant term, which is this number right here, and you want to list all possible factors of that number. Okay, so I'm just gonna say plus minus so I don't have to repeat myself. Always start with 1 and finish with 12. And then you're looking for everything in between, right? So what it can 12 be divided by, and so that you get just a whole number. So if I were to divide 12 by 2, that is a 6. So 2 and 6 are factors, but possibly I have more. So let's see if I can divide this by 3. So yes, 3 and actually 4 was also a factor. Now you can check it out and try all the other ones. You do not need to go past 12 because that's the largest possible factor you can have. And you will see that none of the other ones give you a integer. So that's it for 12. Next, in this particular case, because the leading coefficient, like I said, is not 1 anymore, it's 2. So now you have to also figure out all of the factors of 2. So that would be again plus minus. You start with 1 and with the number, but there's nothing in between anyway. So 2 only has factors as plus minus 1 and plus minus 2. So to find all possible zeros, all possible rational zeros, so not like all zeros, but all possible rational zeros. Rational means either integer or a fraction. So to find them, what you do is you're gonna first take the numbers that you see on the top and divide each of them by 1. So it's gonna be this with that, like, so basically dividing everything by 1. And so that will be 1 over 1. Well, that's 1. 2 over 1 is 2, and so on. So this is just going to be rewritten, okay? And of course, the plus minus. Okay, and then you're going to do the same thing, but this time you divide everything by 2. So you start with the top numbers and divide all of these guys by 2. Okay, so that's going to make it a what? 1 over 2, so that's another one. Then I'm going to go 2 over 2, that's 1, but I already have 1, so I don't have to list it. 3 over 2, all that I did not have. And of course, this is still plus minus. Okay, and then 4 over 2, that's 2, I already have it. 6 over 2, that's 3, I already have it. And 12 over 2, that's 6, I already have it. So there is nothing else there, so I got all possible rational roots, and I can go ahead and write them here. So it's 1, 2, 3, 4, 6, 12, 1 half, and 3 halves. Now what I want to do is determine which of them are actual zeros of my function. Okay, so what I can do is open up the calculator, and I'm going to just delete everything that's there and insert my polynomial. So 2 times x cubed. Instead of x, I put parentheses, plus 5. Again, x is going to be squared, minus 4, parentheses, minus 12. And now I don't have these many, but remember that each of them is like plus minus. So I can try and check the 1 and see if that's a root. No, it's not, because if it were a root, I would get a 0 here. So let's check -1. That's not a root. Okay, so I'm out of luck there. Okay, so let's check 2. That's not it. Okay, let's check -2. And that is it. Okay, so I found -2 is one of the roots. So that's great. So -2, I'm going to write that down. So x equals -2 is one of the roots. Okay, but do I have any more? Well, possibly. We can check 3. If it becomes too hard, we might get into the, because 3 is not working, into using the quadratic formula and synthetic division. Okay, so -3 is also not working. Let's see if we can go to 4. If it's too long, we'll try it another way. Okay, 4 does not work. and negative also doesn't work. Okay, so then what I'm gonna do is, if I just get too lazy to check all of them, you can then go ahead and, knowing already that x equals -2 is one of the zeros, then you can do synthetic division. So you're gonna do 2, 5, -4, -12. Okay, so bring the 2 down, then multiply. This is going to be -4. Add them up, that's 1. Multiply these two, -2, -6 times -2, that's 12, that's 0. So that already confirms that I was right, because my remainder is 0, so I know -2 is one of the possible roots. Then what I do is I solve a quadratic equation. So remember, when we started with the third degree and divided by just one factor, we would get like this would correspond to x squared, this would correspond to x, and the numbers -6 is just going to be the constant. So this is your A, B, and C for quadratic formula. And that is what I am going to use right now. So I'm going to say, okay, let A be 2, let B be 1, and let C be -6. Let me compute the discriminant, which is b squared minus 4ac. So I got 49. Okay, and then I set up the quadratic formula. So press on division, and then I'm going to do minus b plus square root of d divided by 2a. So that's one of the answers, and that is 3/2. So that was inside my list, but it was just too long for me to check them all. So this is a faster way to do it. And so I know that 3/2 is 1. And let's check if I put negative. I got another -2 again. So if I got -2 twice, because I already had it as a factor, but then I got it again over here. So this is going to be multiplicity 2. And so overall, I will have -2 with multiplicity 2, and 3/2 has to have only multiplicity 1, because the sum of the multiplicities has to be equal to the degree, which is 3 again. All right, now how do I come up with the form that I can put in the last blank with the factored form? Okay, so let me discuss that with you. So if I have a 0 of x equals -2, what factor does that correspond to? So remember, this should be the same thing as solving x plus 2 equals 0, right? So x equals -2 is x plus 2 equals 0. So this is going to correspond to, this guy will correspond to x plus 2. So that will go here. Okay, now what about 3/2? So x equals 3/2. Here it's going to be a little bit trickier because of the fraction. Okay, so that should correspond to, theoretically, x minus 3/2 equals 0, right? So you think that that corresponds to x minus 3/2. However, when you have this sort of fraction, what usually will happen is you would want to take this guy, what's on the bottom, and move it to the front of x. So this will actually correspond to 2x minus 3. And you can see that if you were to try to solve this for x, you would add 3 to both sides and then divide by 2, and you will get 3/2. So the 3/2 actually correspond to 2x minus 3 factor. And which one has highest multiplicity? -2, right? So this one supposed to be raised to the power 2, and 2x minus 3 will just be power 1, because that has multiplicity 1.